Good afternoon, learners! Magandang hapon! Welcome to TV Eskwela. I am Teacher Pril Ann Etis Liquido of Pantucan National High School, Pantucan North District, and I will be your guide in learning interesting lessons in mathematics for grade 9. Are you all excited? That's great! Now, I'd like you to grab and open your first module in Math 9 and follow me through. In this lesson, you are expected to define and illustrate quadratic equation, differentiate quadratic equation from the linear equation, write a quadratic equation in standard form and identify the values of A, B, and C, formulate a quadratic equation to represent a real-life situation, and appreciate the uses of quadratic equation in real-life situations. Okay, let's get the ball rolling! When you were in grade 7 and grade 8, in math, you learned about linear equations. As a recall, what are linear equations? You're right! Linear equations are first-degree equations as it has 1 as the highest exponent of variable or variables. Examples are b plus 2 equals -5 and 3x plus y equals 10. Both are examples of linear equation since these equations contain the variables b and x and y with 1 as the highest exponent. Always remember, when the exponent is 1, it is more proper that it remains unwritten. Likewise, whenever you don't see an exponent in a mathematical expression, it is understood that the exponent is 1. This time, I want to find out how well you know linear equations with the activity Post Me in the Right Path. I'd like you to identify the following equations as linear equation or not a linear equation. The straight path on the first column is where you will post the linear equations, while the curved path on the second column is for the equations which are not linear. Please choose the right path. I will give you 20 seconds to do that. Your time now begins. All right, your time is up. Let us now reveal the right path for each of the equations. 3s plus 21 equals 0. 5t plus 7 equals 0. 8k minus 3 equals 0. And 9 minus 4x equals 0. These are the linear equations or first-degree equations since each variable has the highest exponent 1. The equations on the curved path are 2m squared minus 8m equals 0. R squared plus 8r plus 16 equals 0. X squared minus 2x minus 3 equals 0. X squared minus 5x plus 3 equals 0. R squared minus 16 equals 0. And 4x squared plus 4x plus 1 equals 0. These are not linear equations. Have you posted the equations in the right path? Well then, congratulations! You are really doing great with linear equations. Now, let's take a look at the equations which are not linear. What common characteristics do these equations have? Correct! Each variable of these equations has the highest exponent to, or these are second-degree equations. Can you guess what kind of equation are these? Nice try! These are examples of quadratic equation. This time, we will properly define quadratic equation. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the following standard form: ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. This equation has three terms. Ax squared is the quadratic term, bx is the linear term, and c is the constant term. A is the numerical coefficient of the quadratic term, b is the numerical coefficient of the linear term, and c is the constant. I would like to emphasize that in a quadratic equation, a must not be equal to 0. Why do you think a must not be equal to 0? And what happens to the equation when a is equal to 0? The value of a must not be equal to 0 because it is the numerical coefficient of the quadratic term. If a is equal to 0, the quadratic term becomes 0, making the equation no longer a quadratic equation, rather a linear equation. Did you get it? Great! It is very important that we can identify the values of a, b, and c in a certain quadratic equation. To do that, our quadratic equation must first be in standard form or in the form ax squared plus bx plus c equals 0. Here are some examples. Identify the values of a, b, and c in each of the following equations. First example, 3x squared plus 7x minus 1 equals 0. This quadratic equation is already in standard form. Therefore, we can easily identify the values of a, b, and c in this equation. A equals 3, b equals 7, and c equals -1. Did you get the correct answer? Good to hear that. Now, let us try something challenging. This time, we will use some of the mathematical concepts you learned in the previous years. Second example, 2x times the quantity x minus 4 equals 12. This is a quadratic equation. However, this is not written in standard form. To transform it to its standard form, first, expand the product by using the distributive property to the left side of the equation. This now becomes 2x squared minus 8x equals 12. To make the right side of the equation 0, use the subtraction property of equality. That means we will subtract 12 from both sides of the equation. Therefore, the standard form of the equation 2x times the quantity x minus 4 equals 12 is 2x squared minus 8x minus 12 equals 0. We can now identify the values of a, b, and c. A equals 2, b equals negative 8, and c equals negative 12. Did you arrive at the correct answer? Very good! Do you want an equation that is a little more exciting? Check this out! Third example. The quantity x plus 1 times the quantity x minus 8 equals negative 9. This is also a quadratic equation, but is not written in standard form. To deal with the left side of the equation, use the distributive property or the FOIL method in multiplying two binomials. The quantity x plus 1 times the quantity x minus 8 equals negative 9 now becomes x squared minus 8x plus x minus 8 equals negative 9. Then, by combining like terms, the result is x squared minus 7x minus 8 equals negative 9. The left side of the equation is now all good. It's now time to make the right side of the equation 0. To do this, use the addition property of equality. That is, we will add 9 to both sides of the equation. Finally, the standard form of the quantity x plus 1 times the quantity x minus 8 equals negative 9 is x squared minus 7x plus 1 equals 0, where a equals 1, b equals negative 7, and c equals 1. Why is a equals 1? Remember that, just like exponents, whenever you don't see any number before a variable in a term, there is an implied or unwritten 1 there as its numerical coefficient. In our example, x squared minus 7x plus 1 equals 0, there is an unwritten 1 before x squared. That is why a equals 1. There could be instances that b equals 0, and this results to the quadratic equation of the form ax squared plus c equals 0. Examples are 3x squared minus 1 equals 0. Negative 5x squared plus 3 equals 0. And x squared minus 1 equals 0. While equations such as 4x squared minus x equals 0, negative x squared plus 5x equals 0, and negative 2x squared minus 5x equals 0 are quadratic equations of the form ax squared plus bx equals 0. In each equation, c is equal to 0. So, you are already familiar with the definition and basic concepts of quadratic equations. This time, let us see how quadratic equations can be illustrated in real-life situations. Let us consider this situation. Staying at home is the best way to keep yourself safe during this COVID-19 pandemic. To keep you and your siblings cool at home during this summer break, your mother decided to construct a swimming pool in your backyard. She asked you to make a layout of a rectangular pool whose area is 28 square meters. She specified that the length of the pool must be 3 meters more than its width. How can we illustrate this situation using quadratic equation? We can do that by answering these guide questions. 1. If we let x represent the width of the rectangular pool, since it is not yet known, how would you represent the length? Since your mother specified that the length of the pool must be 3 meters more than its width, if we let x be the width, then the length would be x plus 3. 2. You know that the formula for the area of a rectangle is area equals length times width. How would you represent the area of the rectangular pool? Given that the area is 28 and the width is x, and we represented the length as x plus 3, we can substitute all these to the formula for the area of a rectangle. That is, area equals length times width becomes 28 equals the quantity x plus 3 times x. Applying the distributive property to the right side, the resulting equation is 28 equals x squared plus 3x. By symmetric property, this is the same as x squared plus 3x equals 28. How would you describe this equation now? Correct! This equation is a quadratic equation. This means that we can surely use quadratic equations in illustrating real-life situations. To know further where and when we can use quadratic equation, you may also watch a video online with the link below. Going back to the equation we formulated, x squared plus 3x equals 28. Do you want to transform it to standard form and identify the values of a, b, and c? Oh, I hear a yes. I will give you time to do so. Now, will you tell me your answer? Perfect! The standard form of x squared plus 3x equals 28 is x squared plus 3x minus 28 equals 0. where A equals 1, B equals 3, and C equals -28. Do you think we can use that equation to find the length and the width of the pool? Yes, of course! And that will be our lesson on the next episode. So, you already know what are quadratic equations and how they are illustrated. You also learn how to transform quadratic equations to standard form and identify the values of A, B, and C, and how to represent a particular real-life situation using quadratic equation. I am pretty sure that you are now ready and excited to do the activities on your module. Best of luck! Indeed, this afternoon is Math Ganda at Math Saya. Again, I am teacher Pril Ann Etis Liquido of Pantukan National High School, Pantukan North District, saying, dito sa TV Eskwela, sa pag-aaral, sama-sama. Bye-bye!